Hello students, welcome to the concept directivity. This is one of the antenna parameters. This directivity explains us how the radiation pattern is directed towards one direction. Okay? Yes. What is the definition of directivity? Directivity of an antenna is defined as the ratio of the radiation intensity in a given direction from the antenna to the radiation intensity averaged over all directions. Okay? Yes, it is the ratio of radiation intensity in one direction and the radiation intensity averaged over all directions. Okay? Yes, take one antenna. Antenna will radiate one signal. If you want to find the directivity of an antenna, you have to get two things. One thing is radiation intensity in one direction. Assume one direction. In that direction, you measure the radiation intensity and then you measure the radiation intensity in all directions. Average radiation intensity in all directions. That gives you the directivity. Okay. Yes. The average radiation intensity is given by, that is P radiated by 4 pi. What is P radiated? Total power radiated. Okay. Therefore, the directivity is, yes, it is U by U naught. What is U? It is the radiation intensity in one direction. And what is U naught? Average radiation intensity in all directions. And we know the average radiation intensity is P radiated by 4 pi. So if you substitute P radiated by 4 pi in the place of U naught, yes, what is this? The average radiation intensity is U naught. Okay, now if you substitute P radiated by 4 pi in the place of U naught, then you get directivity D, U by U naught, that is 4 pi U by P radiated. Okay, so this is the definition of directivity. ఇప్పుడు నేను last videos లో radiation intensity concept లో is we got the radiation intensity of isotropic radiator as P radiated by 4 pi. Okay, so మరి ఇప్పుడు మరి directivity ఫార్ములాని ఏం చెప్పుకోవచ్చు? Yes, P radiated by 4 pi అనేది radiation intensity of isotropic radiator అయినప్పుడు, ఓకే, అంటే U naught అంటే average radiation intensity అంటే it is nothing but radiation intensity of isotropic radiator అయినప్పుడు, then directivity can be defined as, yes, this is the definition. So the directivity of non-isotropic source. What is this non-isotropic source? General antenna which is not isotropic. Source means radiator, means antenna. So the directivity of an antenna is equal to the ratio of its radiation intensity in a given direction, that is U, over that of an isotropic source. Okay? అంటే ఇక్కడ directivity అంటే ఎలా చేయొచ్చు? సింపుల్ గా radiation intensity in one direction divided by radiation intensity of isotropic source. That's nothing but radiation intensity of any antenna. ఓకేనా? డినామినేటర్ లో ఐసోట్రోపిక్ సోర్స్ ఎందుకు వచ్చింది? రేడియేషన్ ఇంటెన్సిటీ ఆఫ్ ఐసోట్రోపిక్ సోర్స్ ఎందుకు వచ్చింది అంటే యాక్చువల్ గా డిఫైన్ చేసింది ఏంటి? U by U naught అని. వాట్ ఈస్ U? రేడియేషన్ ఇంటెన్సిటీ ఇన్ వన్ డైరెక్షన్. వాట్ ఈస్ U naught? యావరేజ్ రేడియేషన్ ఇంటెన్సిటీ. బట్ యావరేజ్ రేడియేషన్ ఇంటెన్సిటీ అంటే ఏంటి? P రేడియేటెడ్ బై 4 pi. టోటల్ పవర్ రేడియేటెడ్ ని 4 pi సాలిడ్ యాంగిల్ తో డివైడ్ చేస్తే, టోటల్ సాలిడ్ యాంగిల్ తో డివైడ్ చేస్తే మీకు వచ్చేది యావరేజ్ రేడియేషన్ ఇంటెన్సిటీ. కానీ యావరేజ్ రేడియేషన్ ఇంటెన్సిటీ P radiated by 4 pi అనేది ఎవరికి ఫార్ములా అంటే, దిస్ ఇస్ ద ఫార్ములా ఫర్ రేడియేషన్ ఇంటెన్సిటీ ఆఫ్ ఐసోట్రోపిక్ సోర్స్. అలాంటప్పుడు డైరెక్టివిటీ ఏమవుతుంది? U by means the radiation intensity in one direction divided by the radiation intensity of isotropic source. Okay, so that is up to this. Then how to get the maximum directivity? Directivity general formula kada. Maximum directivity కావాలంటే మీరు ఎలా తీసుకోవాలి న్యూమరేటర్ ని అంటే, మాక్సిమం రేడియేషన్ ఇంటెన్సిటీ ఎక్కడ ఉందో ఆ రేడియేషన్ ఇంటెన్సిటీ తీసుకోవాలి. యు హావ్ టు కన్సిడర్ ద మాక్సిమం రేడియేషన్ డైరెక్షన్. ఆ డైరెక్షన్ లో అంటే ఎటువైపు అయితే మాక్సిమం రేడియేషన్ ఉంటుందో ఆ మాక్సిమం రేడియేషన్ దగ్గర ఆ మాక్సిమం రేడియేషన్ కి ఎంత రేడియేషన్ ఇంటెన్సిటీ ఉంటుందో దట్ ఈస్ U max divided by the normal thing U naught. Okay, so and you know U naught is P radiated by 4 pi. So the maximum directivity D max is equal to 4 pi into U max by P radiated. Okay ma? Yes. Now are there any dimensions for the directivity? ఏమన్నా ఉన్నాయా? డైరెక్టివిటీకి డైమెన్షన్స్ ఏమన్నా ఉన్నాయా? లేవు. బికాస్ రేడియేషన్ ఇంటెన్సిటీ and and ఇది కూడా radiation intensity. Numerator and denominator both are radiation intensities. So the directivity is a dimensionless quantity. Okay. Is now for isotropic source. Suppose నేను ఇక్కడ ఒక ఐసోట్రోపిక్ సోర్స్ కనుక డైరెక్టివిటీ కనుక్కోవాలంటే వాట్ ఇస్ డి, అప్పుడు న్యూమరేటర్ అండ్ డినామినేటర్ రెండు ఏమైపోతాయి, సేమ్ అవుతాయి కదా. ఐసోట్రోపిక్ రేడియేటర్ అంటే ఇట్ వోంట్ రేడియేట్ ఇన్ వన్ డైరెక్షన్, ఇట్ విల్ రేడియేట్ ఇన్ ఆల్ డైరెక్షన్స్ ఈక్వల్లీ. అప్పుడు మీకు న్యూమరేటర్ అయినా డినామినేటర్ అయినా ఏదైనా ఈక్వల్ అవుతుంది. సో ద డైరెక్టివిటీ D becomes 1 as U naught అన్నా U max అన్నా అన్నీ ఒకటే, అన్నీ ఈక్వల్, because isotropic radiator radiates equally in all directions. That is the reason you'll get the directivity as 1. So remember, isotropic source ka aithe directivity 1, non-isotropic sources ka aithe means non-isotropic antennas ka aithe eppudu directivity greater than 1 untundi. Remember, okay? There exists the term called partial directivity. Under directivity there is partial directivity. See, for the analysis of antenna radiation pattern, we know we are using spherical coordinate system. The coordinates are r, theta, phi. Okay? Always consider any analysis in the far field region. Far field region ante ela untundi anante always the field is in the radial component. Ante AR direction lo field velipothu unte AR direction lo field velipothu unte ante wave velipothu unte daniki perpendicular directions lo components untayi. Okay, what are the perpendicular components now? Theta and phi. What are the perpendicular directions now? Theta and phi. Okay na? So ante ikkada two types of I can say polarizations ante a field components untayi, a direction lo untayi. Ante direction of field components ni express cheyadaniki manam use chese word polarization. Okay, future classes lo chudru gaani. Yes sir. So ఇప్పుడు మనకి టూ పోలరైజేషన్స్ ఉన్నాయి. ఒకటి ఏంటి, థీటా పోలరైజేషన్ అండ్ ఫై పోలరైజేషన్. అవునా? అంటే థీటా డైరెక్షన్ లో ఎలక్ట్రిక్ ఫీల్డ్ అండ్ మ్యాగ్నెటిక్ ఫీల్డ్స్ ఉంటాయి, ఫై డైరెక్షన్ లో కూడా ఎలక్ట్రిక్ ఫీల్డ్ అండ్ మ్యాగ్నెటిక్ ఫీల్డ్స్ ఉంటాయి. ఓకే, ప్రాపగేషన్ ఏమో ఏఆర్ డైరెక్షన్ లో వెళ్ళిపోతూ ఉంటుంది. ఓకేనా? సో ఈ కాన్సెప్ట్ తో ఇక్కడ మనం పార్షియల్ డైరెక్టివిటీ అనే ఒక టర్మ్ ని మనం డిఫైన్ చేయబోతున్నాం. ఇప్పుడు పార్షియల్ డైరెక్టివిటీ అంటే ఇట్ డీల్స్ విత్ దీస్ టూ పోలరైజేషన్ సెపరేట్లీ. ఎలా ఉన్నది? That part of the radiation intensity corresponding to a given polarization divided by the total radiation intensity averaged over all directions. Okay, ante ippudu manam theta and phi ane two directions unnai, ante theta and phi ane two polarizations unnai. Okay, ee two polarizations lo ante two different directions lo ante theta direction lo and phi direction lo pattern velipothu untundi kabatti we get two directivities. Those directivities are called partial directivity. Okay, so if the partial directivity formula, suppose if you consider the theta polarization, then the partial directivity d theta is equal to, see here, it is u theta by u naught. What is u theta? And theta direction lo unna radiation intensity enta. Okay, adina that part of the radiation intensity corresponding to given polarization. What is the polarization? Theta polarization. Okay, so answer is u theta by u naught. What is u naught? Normal, it is the average radiation intensity, and you know the average radiation intensity is P radiated by 4 pi telusinde manaki. So it is totally 4 pi u theta by P radiated. Ippudu P radiated ante enti, total power radiated kada. Ee power radiated rendu directions lo velthu untundi kada. So manam partial directivity d theta chesetappudu you have to consider the total power radiated. Total power radiated ni ela rayachu? Yes, power radiated in theta polarization means theta direction, and power radiated in phi direction. Okay, so this is the partial directivity d theta. Mari phi kuda alane untundi kada partial directivity. So d phi, that is u phi by u naught, again 4 pi u phi by P radiated. So it is 4 pi u phi by P radiated in theta direction and P radiated in phi direction. Okay, so these two are called partial directivities. You total directivity ni ee partial directivities use chesi kuda kanukovachu. Enti formula? The total directivity D is equal to partial directivity in theta polarization plus partial directivity in phi polarization. Okay, so this is the directivity in terms of partial directivity. Okay na, clear ga unda? Next point enti anante Yes, you have the directivity in terms of the beam solid angle also. What is the directivity? D is equal to 4 pi by omega A, where omega A is called beam solid angle. Ikkada manaki beam solid angle in terms of radiation intensity enti formula ante, so this is the formula of beam solid angle. Yes, say this is, and you know already the solid angle d omega. Okay, ఇప్పుడు చూడండి omega A అంటే ఏంటంటే, yes, ఈ ఫ్యాక్టర్ ని, what is this factor? This is the normalized radiation intensity. Why it is normalized radiation intensity? ఏ ఫ్యాక్టర్ నైనా సరే దాన్ని maximum value తో డివైడ్ చేసి, that is called normalized factor. What is this u of theta comma phi? Radiation intensity. Okay, and what is u max of theta comma phi? Maximum value of that particular radiation intensity. So it will be totally normalized radiation intensity. మీరు ఆ normalized radiation intensity ని total solid angle లో మీరు ఏం చేస్తున్నారు? You are finding a total solid angle, that is nothing but beam solid angle. Okay, yes sir. So this is the directivity in terms of beam solid angle. Okay. This is an extension point of directivity. Suppose we want to find the directivity of a directional pattern. What is by directional pattern? The pattern, and the directional pattern, the radiation is maximum in one direction. Okay, so for that type of directional patterns, see here, for antennas with one narrow major lobe and very negligible minor lobes. అంటే మేజర్ లోబ్ ఒక్కటే ఉంది అంటే, సపోజ్ నా ఇఫ్ యూ టేక్ దిస్ pattern like this is one narrow major lobe and very negligible minor lobes. చాలా చిన్ని minor lobes ఉంటాయి. For this type of radiation pattern, means only major lobe is the maximum thing here and you can neglect the minor lobes. For this type of radiation pattern, yes, the beam solid angle omega A can be written as theta hp into phi hp, where theta hp is the half per beam width in theta plane and phi hp is the half per beam width in phi plane, and these two are in radians. The half per beam widths will measure in radians. Okay, so and remember this is called the directional pattern. చెప్పాను నేను already, directional pattern అంటే ఒక డైరెక్షన్ లోనే maximum radiation ఉంటుంది compared to all other directions. For that type of pattern, yes, this is the beam solid angle formula. So you can write the directivity 4 pi omega A as 4 pi theta hp and phi hp, and theta hp phi hp are in radians. Suppose if you convert this theta hp and phi hp in degrees, we know pi radians is equal to 180 degree. Okay, then what about 1 radian? 1 radian is 180 by pi and 1 degree is pi by 180. Okay, so if you want to write this as degrees, then you have to, yes, do like this. Okay, ela vachindi idu ardhamaindamma? Yes, pi radian is equal to 180 degree. So ఇప్పుడు degrees లో కావాలి అని అంటే ఈ radians ని ఏం చేయాలి? Yes, ఈ pi radians divided by ఈ 180 ని తీసుకొచ్చేస్తే మీకు ఏమవుతుంది? You'll get it in degrees. Okay, so అది డినామినేటర్ లో ఉంది కాబట్టి న్యూమరేటర్ లోకి వెళ్ళిపోయేటప్పటికి yes, pi by 180 కాస్త 180 by pi అవుతుంది. So as you have two terms, I'll get square here. Okay, so if you calculate this, you'll get 41,253 by theta hp and phi hp in degrees. Okay, yes. Now for planar arrays, future లో చూస్తాం array antennas అనేసి. అలాంటి antennas కి చాలా బెస్ట్ అప్రాక్సిమేషన్ వచ్చేటప్పటికి ఈ వాల్యూ 32,400 by theta hp degrees and phi hp in degrees అవుతుంది. ఓకే, yes, అంటే ఆ వాల్యూకి మీకు పర్ఫెక్ట్ డైరెక్టివిటీ వస్తుంది అనే మీనింగ్ అన్నమాట అక్కడ. yes, now and coming to the, this is directional pattern concept, and coming to the omnidirectional. what is omnidirectional? మనం పాస్ట్ వీడియోస్ లో చూసిన omnidirectional అంటే ఒక వైపేమో డైరెక్షనల్ ప్యాటర్న్ ఉంటుంది, ఇంకొక వైపేమో నాన్ డైరెక్షనల్ ప్యాటర్న్ ఉంటుంది. ఓకే, అంటే ఒకవైపు డైరెక్షనల్ ప్యాటర్న్, ఇంకొక వైపు నాన్ డైరెక్షనల్ ప్యాటర్న్. ఆ నాన్ డైరెక్షనల్ ప్యాటర్న్ అంటే ఐసోట్రోపిక్ కూడా అవ్వచ్చు. ఐసోట్రోపిక్ ఇస్ నాన్ డైరెక్షనల్. ఓకే, అలా కనుక ఉంటే దట్ ఈస్ కాల్డ్ omnidirectional pattern.
See this is the omnidirectional pattern. You know the omnidirectional pattern which has directional properties in one direction and non-directional properties in another direction. That non-directional may be isotropic also. So if you say this pattern is in this direction, that is in phi direction, it is actually isotropic, and in theta direction let us see this, these are all directional patterns. This lobe is directional pattern, this is directional pattern. Okay, so this is isotropic pattern, means non-directional, and this is directional. So this is the omnidirectional pattern with minor lobes. See, all these are minor lobes, and this is the omnidirectional pattern without minor lobes.
Suppose if the omnidirectional pattern is consisting of some small minor lobes, then the directivity is approximated like this. Okay, derive cheyalsina pani ledamma, just meeru gurtupattukunte chalu. 101 by HPBW in degrees minus 0.027 HPBW in degrees square. Okay, HPBW అంటే ఏ ప్లేన్ ఏదైనా మీరు తీసుకోండి, either theta HP or phi HP, but you have to consider it in degrees. The same directivity in the case with no minor lobes. ఒకవేళ omnidirectional pattern లో కనుక minor lobes లేకపోతే you can approximate the directivity as minus 172.4 plus 191 root 0.818 plus 1 by HPBW in degrees. ఓకేనా, ఈ రెండింటి ఏమో డెరివేషన్స్ అవసరం లేదు, జస్ట్ మీరు గుర్తుపెట్టుకోండి, ప్రాబ్లమ్స్ వస్తే వీటన్నిటిలో సబ్స్టిట్యూట్ చేసి మీరు కనుక్కోవాలి. ఓకే, సో దిస్ ఇస్ అబౌట్ ద డైరెక్టివిటీ ఫర్ omnidirectional and directional patterns. ఓకే, సో టోటల్ గా డైరెక్టివిటీ మనం చేసింది ఏంటి అని అంటే, we define the directivity, that is U by U naught, and we came to know that it is nothing but the radiation intensity in one direction divided by the radiation intensity of isotropic radiator. And for the isotropic radiator, the directivity is 1, and for all other antennas, directivity is greater than 1. ante kada, numerator lo nemo radiation intensity in one direction ani, denominator lo average chesinappudu always average is lesser than the radiation intensity in one single direction, because we generally consider the maximum radiation direction. Okay, then we define the partial directivities d theta and d phi, and total directivity d is equal to d theta plus d phi. Okay, then the directivity in terms of beam solid angle, the directivity in terms of beam solid angle is d equal to 4 pi by omega a, and the beam solid angle omega is nothing but integration of the normalized radiation intensity in the solid angle, in the total solid angle. Okay, then for the directional patterns means major lobe manchigundi ikkada, minor lobe ganaka lekapothe, you can approximate the beam solid angle as equal to the product of theta HPPW and theta HP and phi HP, where theta HP and phi HP or HPPW means half per beam width and theta plane and phi plane respectively. Generally we will measure them as radians, and degrees lo convert cheste you will get this formula 41,253 by theta HP in degrees and phi HP in degrees. Okay, for planar arrays this is the formula, and for omnidirectional patterns, minor lobes, this is the directivity, and without minor lobes that is the directivity. So this is about the major part of directivity, which is a figure of merit of an antenna. What performance you can measure with the directivity, as said in the starting, it is used to find the directional properties of an antenna. Okay, so thank you very much.